Welcome back to my channel. You may have noticed that I rebranded this series to Let's Build a Tetris-Like. I think from now on, I'm going to kind of stick with that sort of terminology, and I'm going to have little like surveys to see what type of game I should build next until I'm ready to build something significantly bigger. I do have a game in mind that I want to build, but just to kind of get this channel started, I'm going to go through the basics, and we're starting with the Tetris-like. So if you're interested, check out the community tab and vote on the next game that I build. I think I gave 4 choices for the next one. Anyway, so let's take a look at my Trello board that I had here. I added some new tasks, and where I last left off, I was working on the active area textures. That I was just getting from Megascans. I did find one that I liked better. Let's open up. This was meshes, active slice is what I did. All right, so I found a different marble that kind of fit the unwrapping job that I did for the active slice area better. I like it. I didn't go like full high res with it. And I don't think it had like a normal map. At least it doesn't seem to. Where we have an albedo and an ARD. Yeah, no normal, it doesn't look like, but that's okay. I mostly just wanted to get something shiny with a little bit of visual interest to it. Anyway, so let's close this back down. That is now that task. I'm calling it finished. There we go. So the next things that you may have noticed that I did already, but I'm going to walk through them. It's probably a lot less painful for me to do it first and then show it afterwards. But I started with a block-based C++ class. And to do that, I just went down to my C++ classes. I right-clicked, said new class, and I chose an actor for this one, I believe. So let's open it back up. The idea here is to have like a generic class for the blocks that is going to be it's going to have inherited or child classes that inherit the attributes of it. So what I did here was I knew it would need a mesh, I knew it would need a collision, so I gave it a block collision, or I called it a block collision. A U box component is what it takes. I'm making sure that I can read and write these in blueprints because that's where I'm going to be changing most of the defaults. But I'm setting it up to only be editable in the default parent class. So this I'm going to use later, prefaced with B because it's a bool and it's going to be the check that I have if it's actually colliding. I'm going to set this up to collide based on overlaps and not on blocking collisions. I'm going to handle the blocking myself. And then just thinking ahead a little bit, I created an enum to hold all the different types of tetraminos there are with a default, and this is what's going to be assigned to the base class. So then we have the constructor, the tick, that's all boilerplate. These I'll get to in a later video, but this is something I was testing around with. There's some kind of interesting things here. Even though I'm not considering this like a tutorial, I do kind of want to go into like the nuts and bolts of how things are working and how I figured out how to do them. And since I do have the tetramino type as protected, I did need to create a public setter for it. Actually, I'm not sure if that should be a force inline. Maybe it should be. It's not really doing much. I mean, because it is only just a couple of lines. I forget what all force inline does. I want to say, I mean, I know what it does. It replaces any instance of this function with the code that's in here, and I think it being inline helps with performance so that the code isn't jumping around for like one line of thing that can just be inserted. So I think force inline is probably good for setting the tetraminnow type. So if you go over to the block base where I'm setting it, all it is taking in an tetraminnow type and setting the type so that the block knows what it is. This I'm not even sure I'm going to need on the block now that I think about it. That's going to be more for the tetraminnow side. But anyway, so once I created that, I went back over here, right-clicked, and I said create blueprint based on block base. And block base is right here. The naming standard is prefaced with BP underscore, so that's how I set it up. And let's take a look at some of the things I created here. So in the C++ class, I have a block collision and a block mesh. That was about all it really had. And so for the block mesh, I just gave it the default of I. I mean, I could just have like a blank thing in there, and it's using the material that all my blocks are going to use. It probably doesn't need tick enabled. That's something I can mess with in C++ later. But the real interest here is when you start creating derived classes. So actually, I'll get into this after I explain tetraminnow. So I created a tetraminnow base C++ class. And let's go in there, just double click it. So I don't have a whole lot in here yet, but it's going to have 4 blocks because all tetraminnows have 4 blocks. Going to be read-only in the blueprints, but visible anywhere. So I can see it changes as they happen in the pie. Yeah, and then blueprint read write and edit defaults only on a block base. And this is kind of where the nuts and bolts here. More the blueprint that I'm gonna be spawning. This is where you set this. A T subclass of the C++ class. But since it's a subclass, it will accept a blueprint. And then this is what I set over here in the blueprints. And then the block positions is where they're actually gonna be. And it's not specifically where the block positions are. No, this is still block base, tetraminnow, C++. Yeah, so these I'm setting as a local vector. So these are going to correspond to all the possible positions that a block is going to have in the tetraminnow. Right now, for the O, well, this is going to be the default. I'll get into the O block when I get there. But essentially, I default it to be a 9x9 area locally of -100 because that's how many centimeters my block mesh is. So that's going to be the block positions. I think that's all I'm really setting in here. Yeah, since this is just a base class, I think that's all that I need to go into there. So from there, now that I have a block base and a tetraminnow base, I was able to create a blueprint. Go back up here. This is the tetraminnow base. Full blueprint editor. And over here is where you have just the default scene root, because all this is going to do is hold positions for all these block bases. and I had to set this to BP block base to get it to take the blueprint. But when I created the O class, go down there now, this is where things really start to come together. Let's double click this. So we already have block positions and everything all set up. Here's the header file, so I didn't need to do anything here. I already know that the block positions are in that 9x9 grid, and here is where I'm spawning the actors. The Tetramino itself is essentially just a placeholder for positions. That's how I'm using it anyway. So I'm spawning block actors in the world. They're going to be BP block bases, which I actually, yeah, let's leave this named block base. And then I'm spawning them at the same position with the same rotation as the Tetramino O. And then from there, I'm setting the positions, the relative positions of all four of the blocks that I just spawned. And in this case, 0, 1, it's the 9x9 grid starts at 0, goes from left to right, and then up. So 0, 1, 2, 3, 4, 5, 6, 7, 8. You get the point. So that means that the initial block positions are going to be 0, 1, 3, and 4. All right, let's go back into Unreal Engine. So once I set all of that up, I did a create blueprint derived from that. And here it is. I had to do the same thing with block base. I created a block O, and this is mostly just setting the color information. Hop in here real quick. Something I wanted to double check was, where is it? Block collision. Yes, okay, so this did inherit properly. So I want this to be 1 centimeter less than the size of the actual block. And the reason for that is that these blocks are going to be stacked right next to each other, and even though they're not technically overlapping, you still get overlap events. So if I set it to 50, which is what the block mesh actually is, I would be generating overlap events when it's really just bumped right up against the one next to it. So that's why I did that there. It's set to 49. Although maybe the line, in my testing, it didn't work with 50, but that was on a different project. I didn't notice this line thickness. So maybe since line thickness is 0, maybe it would work with 50. It's something I need to explore later. But in any case, here's the block. I had to give it the type O mesh so it had the correct color. Everything else it just inherited from the base. And let's go over to the Tetramino base. Nothing is going to show up here because it's all being generated from C++. The important thing is I had to set this. Oh, wait, no, I'm still on base. Tetramino O. The important thing is this right here. I had to set BP block O to make sure that this was filled so that I would generate the block blueprint for O. Originally, when I was testing this, I expected it to inherit the BP block base from the other Tetramino class, the Tetramino base class, but it didn't. So for anyone out there who's trying to follow along, yeah, keep that in mind. It will inherit everything else except for the blueprints. Save yourself some trouble. That was quite a headache for me. I didn't know why it wasn't taking the default from Tetramino base. All right, so once we're in there, let's go over to back to Tetramino O, C++. That's what I was looking for. So we're setting all the relative positions. So these should all show up when I hit play when I drag this into the game world and hit play. We should see a Tetramino, and I already tested this, so I know it works. Set it at 0, 0, 0. And there it is, our beautiful O block. So what I'm gonna do real fast, probably off camera, I don't know that I feel like editing in a time lapse here, but I'll do the other Tetraminos and I'll drag them out next to each other and you can see them all after I'm finished. I will be right back. Okay, so I went through every single one of my C++ classes and I derived all from Tetramino base, one for each of the 7 Tetramino types. Then I went up to my blueprints and well, I derived blueprint classes of all those Tetraminos, but then for the blocks, I derived a bunch from the blueprint itself. And the reason I needed to do that, oh, it looks like I did this one incorrectly. Let's delete. Let's go BP block base. So I created a child blueprint, and I already forget which one that was. S Z T I J L. Yeah, I think it was L. Okay, now they're all derived from block base. I must have derived one from block O. But the only difference between all of these is just the static mesh. So I'm going to go through each of them and set the static mesh properly. So we're in Z, go to meshes, and the mesh, stock and layout. Oh, come on. Maybe I will just keep this separate. Well, let's... Alright, meshes. Just a little bit. And what do we need? We're looking for I. Okay, so I is what we used for the base block. Oh no, we're in Z though. Z? Alright, I'll save. Alright, block I is already good. Save you, close you. I. It means I can use BP block I. Perfect. Save. All right, Tetramino J. Block J. Save. L. Block L. S. Z. All right. Back to the blocks now. So Z is all set. Open up all these. It was already set. I. All right, and then for these, let's go back to the mesh. I'm in T. All right, come on, T. Oh, that's not helpful. Back in the content drawer. We're in meshes, T. All right, you get the idea. I'm going to go through and do the rest of them. I'll be right back. All right, now we're back in C++. Time to set up my Tetraminos. So I think what I'm going to do first is copy over the boilerplate that I wrote for O and use it as a template. Copy it over the headers as well as the begin play, because the generated stuff, it doesn't even give you a constructor. Where's a header? Yeah. Oh, these are all headers, and then the C++ itself has absolutely no definition set for it. I'm going to copy that over, and I'll be right back. And finally, we need to go through and set all the block positions for our tetraminnows. I thought I'd show tetraminnow I because it's a slightly different case. Just as a reminder, the positions go 0, 1, 2, 3, 4, 5, 6, 7, 8 in a 3x3 grid. And so for the I piece, it's actually going to go outside that grid. So I need to change the positions from what they are in the base default. And I think what I'll do is the eyepiece only has, well, the way I'm going to set it up, the eyepiece only has two positions, one where it lays flat and one where it's up and down. And I think both of them are going to strike through that middle spot, which will be position 0, 1, 2, 3, 4. So position 4 will be my base point for that. And then we'll go over to the left 1, and then the next 2 on the other side. And then we'll do the same thing for up and down. We'll start at 0 and we'll go up by 2 and down by 1. And I'll change the positions to match that here. All right, let me copy these and I'll be right back. Okay, so I set it up. 0, 0, 0 is going to be block position 0, and then I'm going to go from relative to there. So -1 or 1 meter on the X, and then 1 and 2 over on the X. And then for up and down, it'll stay block position 0, and then down 1 on the Z, and then up 1, and then up 2 on the Z. So to set, once I spawn the actors, the position, the block actors, the position is going to be 0, 1, 2, and 3. I already compiled. Let's jump back over to the editor and check our work. And if this works out properly, I'll do the rest. Blueprints, we want I is just one we just did. I'm not seeing it. What did I miss? All right, blueprint, tetraminnow I, block base, BP block I. Oh, you know what? I might have an idea. Okay, that fixed it. So, well, first let's test it. So there you go. I have the two tetraminnows right next to each other. Let's end this here, and then the problem is that I was setting the relative location directly to the block position, but I wasn't taking into account where the tetraminnow itself was. So once I added that, it moves along with the tetraminnow then. Oh, and I also don't want this to be relative anymore. Set actor location. Save this. Okay, and then I'll do this for the rest of them. I'll set them up and I'll be right back. All right, so I went through, I finished up placing the initial position of the blocks, and I spread them out nice and evenly. For the display, let's try it. Beautiful. Look at that. All right, everyone. We have our Tetra Minnows. I think I'm going to end this here. I hope you enjoyed this video. See you in the next one.